Hello everyone, this is Shahab and I hope you're having a great time wherever you are and you're enjoying the holidays with your families. This is my YouTube channel and in this video we want to talk about three overlooked features of Azure Storage Account, specifically about the Blob Storage. Data redundancy or replication strategies, the second one is lifecycle management, and the third one is shared access signature tokens. So stay with me and let's dig into that. The first topic that I want to talk about is about data redundancy or replication strategies. Azure data centers are distributed geographically into different regions, and they are called Azure regions. And within each Azure region, there are data centers also grouped logically into availability zones. So let's take a look into the architecture diagrams that we need for them. Consider this is an Azure region and named region 1, and it is our primary region that we are deploying our applications there. Within each Azure region, we would have three availability zones. So within the regions, we have three availability zones that are logical groupings of data centers that are sharing the same power, network, and facilities like infrastructure facilities. Azure stores at least 3 copies of our data to make sure that some minimum level of high availability and fault tolerance is implemented. So considering this is our database, let me just remove this label from here. In locally redundant storage, there will be 3 copies of this data in one availability zone. So if one data center in this availability zone is facing an outage, still 2 others are there to satisfy the requirement and provide service to the requests that are coming for this storage account. This is the minimum redundancy level. The next one is zone redundant storage. So in zone redundant storage, instead of having all the 3 copies in the same availability zone, they will be dispersed into these 3 availability zones. The next availability zone is geo-redundant storage. So let me zoom a little bit and copy the whole thing. So the first 2 availability zones, they are not tolerating regional outages. So if region 1 or the primary region is facing some issues, then we don't have access to any of the data, whether we are using LRS, local redundant storage, or ZRS, zone redundant storage. If we need our data to be available in case any regional outages is happening, then we need to duplicate that or replicate those data into another region. In this example, we're calling that region 2 or secondary region. Let me show you how the data would be replicated between region 1 or the primary region and secondary region. So in geo-redundant storage or GRS, there are 3 copies of our data in one availability zone in the primary region, and there are also 3 copies of the same data in another availability zone in the secondary region. This way, if we are facing regional outages, still another region is up and running to serve the requests that are coming to this storage account. Even though geo-redundant storage is providing us with higher availability in regards of region outages, if we face some outage like AZ1 in region 1 is not working properly, or there are issues simultaneously for AZ3 in region 2, we don't have access to our data. So we need another level of replication or a higher level of replication that guarantees more availability no matter which region or which availability zone is facing an outage. And that is geo-zone redundant storage. So the geo-zone redundant storage is a combination of zone redundant storage. That means in the primary region, it is like ZRS. So every availability zone in the primary region has 1 copy of the data. And in the secondary region, we will have all 3 copies inside the same availability zone. So in this scenario, the whole region 1 and availability zone of region 2 should be down for our application not to working, which is very unlikely. So if I want to summarize, we have LRS or local redundant storage, which means 3 copies of the data are kept in one availability zone, and that saves us from node outages, but not regional or zone outages. The other one is ZRS, which is zone redundant storage. That's a little bit better than the first one because the three copies are distributed to three availability zones within one region, and we are protected from node outages or zone outages, but still regional outages is not covered in this scenario. To cover those scenarios, we have two other options. We have GRS, which is geo-redundant storage, and in that scenario, every region, the primary region and the secondary region, each of them have three copies of the data inside one availability zone. And the GZRS, which provides even more fault tolerance for us, it's a combination of LRS and ZRS in different regions. So in the primary region, it is more like ZRS. We have three copies of data in three availability zones, one per each availability zone. And in the secondary region, it is more like LRS, which means that we have all the three copies of this data inside one availability zone. The last two also have a read-only access as well, which means in the secondary region, the data is read-only and there's no write access there. This covers the basics about data duplication or replication strategies that you need to understand when you are creating your Azure Storage account. So let's also go to the Azure portal and see where we could define that. Here I am in the Azure portal. If I click this plus button in here and search for a storage account, here I could create a storage account. I'm not going through all the steps. What I want to show regarding the redundancy strategies is this drop down here. So we have local redundant storage, geo redundant storage, zone redundant, and geozone redundant storage. And this is where you could choose which strategy you might need for your scenarios. Another important thing when we are creating a storage account and we want to have geo redundant storage or geozone redundant storage, is that the region that we are selecting should first have availability zones and second have a paired region. So it will automatically use that paired region as a secondary region for this storage account. Here you see I have chosen West Europe and North Europe is the paired region for this one. But if I change this to, let's say, Austria, consider I want to create it in Austria, and if I'll go here, you will see I have only two options, locally redundant storage and zone redundant storage. Because this region, Austria East, does not have any paired region, so I cannot have geo-redundant storage or geo-zone redundant storage. If you want to know which regions are supporting availability zones and have paired regions so that you could use geo-redundant storage or geo-zone redundant storage, you could go to Azure region lists. And here you will see which ones are having availability zones and do they have a paired region or not. For example, here you will see that Austria East, even though it supports availability zones, it doesn't have any paired region. On the other hand, for example, Canada Central has Canada East as a region. That means we could have geo-redundant storages. That was the first topic in this video that I wanted to elaborate a little bit more on that. The next topic is about lifecycle management. In Azure Blob Storage, there are different access tiers. We have hot, cool, cold, and archive. These four tiers provide us with flexibility about how fast we want to access the data or how frequently we are accessing the data. And then we could put them into different tiers. For example, something that is in the archive tier is something that we barely use. For example, we just keep them for regulatory reasons, or something that is in the hot tier are the files or blobs that we are accessing more often and like maybe every minute or every day we need like to access those files. Storing files in each tier provides us with different cost values. For example, something that is in the hot tier, it has more cost on the storage and less cost on the retrieving of the data. And something that is in the archive storage, it doesn't cost that much when we are storing it, but if we want to retrieve that data, it might cost more. So we always need to find a balance and trade-off between those things. And that is where lifecycle management helps us. It gives us the capability to dynamically, based on some rules that we are defining, we move the files between different tiers. Let's see that in action. I have already created a storage account, and if I go to data storage and containers, if I go to this sample container, you will see that I already have a couple of files. All of them are in the hot tier, but they have accessed a different, or the last modified column points to some different files. Let's say I don't want to keep files that are older than 3 days. After 3 days, we want to delete those files, right? Now let's go back to our storage account. If we go to data management, here we have lifecycle management. We don't have any rules defined yet, so I'm clicking on this add rule. And first of all, let's give it some name, cost optimizations. And I have different options. I could apply the rule to all the blobs in this storage account, or I could limit the blobs with some filters. You see that the third step appeared up at the top, and I could go there and define a filter about which blobs we want this to be applicable. For now, I'm just choosing apply to all blobs. There are two types of blobs that we could store, and they have also some subtypes about the base blob or the snapshots or versions. If that is enabled, you could also apply separate rules for the snapshots and versions. As you see, there are two other steps when I'm checking those checkboxes appear at the top. I'm just ignoring them. Going to the next step, in the base blob, I could say if a base blob is last modified or created more than, let's say, 3 days ago, then delete the blob or just move it to a lower tier like cool tier or cold storage, or just delete the blob. In our scenario, I want just to delete the blob. You could also add more conditions, like if also it is created more than 3 days ago, then you could also do the same thing with that. But let's just move. I would just want that rule. And I want it to be applicable to all the rules that I have. And I've created this. And it says me successfully updated lifecycle management. We have created these rules, and it will take some time for this rule to take effect. And here it is mentioning that a new or updated rule can take up to 24 hours to go into effect. And that was the second feature that I wanted to talk to you about, because it will help you to save a lot of money when you don't have the necessity to frequently access the files, and you just move them to a lower tier, and maybe at some point you could just delete all those blobs. I am back in the storage account that I have created. If we scroll down to the security and networking and access keys, this is where we have keys to access our storage account, and we have two connection strings. So we have key 1 and key 2, and based on that, we could access our storage account. The problem with these two is that they are providing global access to the whole storage account, and we don't have any granular control over the permissions that we want to give the clients to perform certain operations. For example, if the client just needs to list the blobs that are stored in our blob storage, by using these connection strings, they have way more permissions than just listing the blobs inside the blob storage. So a better approach is to use shared access signature. And that is also under security networking, just under the access keys menu. So if I click on the shared access signature, here you will see that I have more granular control over what the client can do when they are connecting to this storage account. For example, I could say they don't have access to the files, queues, and tables. They can just connect to the blob service, and they could also just use the containers resource type. And the only permissions that they have is read and list. We are deleting all the other permissions. We could also define some start time and expiry time. It is always recommended to use a short-lived token, so the expiry time should be as short as possible depending on your scenario. So don't leave it for eternity or for 2 years or 1 year or something like that. Make it as short as possible. And for the start time, it is always a good practice to put the start time a little bit before the current time that now, because of the servers and the clients might have different time zones and these kind of scenarios. Also, you could filter over the IP address. So you could say that only the clients that are connecting from these specific IP addresses are allowed to connect and perform the operations that are listed or allowed at the top. And then the shared access signature it's an encoded string that is signed by a key. It is always signed by a key. So here I could use key 1 or key 2 as the signing key, and those are the access keys that I just showed you recently. So they are the access keys available at the storage account. And when I'm generating the SAS connection string, we'll see there's a connection string or blob service and SAS URL, and there's the SAS token. The SAS token contains all the information that is required to authenticate and authorize the client that is connecting to that. And for example, it has the start date, the expiry date, it has the permissions here. For example, it is listed read and R and L, which is read and list operations. And there are 3 types of SAS tokens: account SAS, service SAS, and user delegation SAS. Account SAS is what we saw already, that we are using the access keys of the storage account to generate the SAS token. The service SAS is at the service level. So if I'll go, for example, to the containers, and I'll choose my container in here, you see I also have a shared access tokens in here. And I could generate a token at the service level. For signing this token, I could still use the global access keys, key 1 and key 2, but I could also use something called stored access policies. The stored access policy is at the service level. It is not at the account level, or it is not at the user delegation level. So if I have an access policy, let's just create one. Let's name it sample access policy. And the permissions that we want, let's say we want read and list in here, and some start time, let's say from yesterday to at most tomorrow. We want it to be valid. And if I click on OK, when you click on OK, don't forget to hit save, because yeah, if you don't do that, you will get some, the tokens are not valid. And if I go back to this shared access token, still I'm at the container level. Now I could see this sample AP, and you see, as soon as I selected that, everything else is disabled. That's because for the permissions and for this expiry and start time, it uses what we have defined in the access policy. One benefit of using this approach is that if these tokens are somehow exposed and we want them all to be invalid, the only thing that we need to do is to go to the access policy and just delete this access policy that we have created. And that means also don't forget to hit the save button. And that means every SAS token that is signed by this access policy will no longer be valid. If we don't use any stored access policy, still we are using the signing keys, the global ones, and we could choose the permissions in here, start time, IP address, everything, and we could also generate the SAS token. The third way to generate SAS tokens, and that is also at the service level, like in the containers or blob service, is to use user delegation key. And you will see this is the second option as a signing method in Portal. So I'm clicking on this user delegation key, and the first thing to notice is that it tells me that I don't have permission to do this operation. And to be able to do this, we need the user that is requesting the generation of this SAS token to be in the role storage blob data contributor. So let's do that first. Going to the access control IAM, let's go to the add role assignment. The role that we need is storage blob data contributor, this one. And going to the members, let's assign it to myself. And then in the review, what I want to show you is here, if I click on the view to see the details about this role, the storage blob data contributor, you will see that the actions that it could do, one of the important ones is generate a user delegation key. This is the permission that we need when we are using user delegation SAS to have this to have assigned to the user or the security principal in general, because the security principal could be a user, a group, a managed identity, whether it's a system assigned identity or a user assigned identity. And if I'll go also to the JSON, you will see that it has data actions, which are read, delete, write, and move or add. And then here we also have generate user delegation key, right? So let's assign this one. It might take some time for this assignment to take effect, and we'll be able to generate the SAS that we want. Great. After refreshing the page and waiting for some time for the token to take effect, if I go again to the container and shared access tokens, now if I click on the user delegation key, that warning is no longer in here. And now I could say I want to the read and list permissions, let's say from a couple of minutes ago, like, I don't know, 5 p.m. At the current time, and until, let's say again, like until tomorrow. And I'm not filtering over any IP address. I'm going to generate a SAS token, and you will see the SAS is also generated. The SAS that is generated by the user delegation key is using Microsoft Entra ID to be signed. So if we want to invalidate all those SAS tokens that are out there signed by this user, we could simply just go to the role assignments and remove that. I'm in a wrong role assignment, because role assignment could be happening at the storage account or at the service account. So let's go back to the service. And here, if I go to the role assignments, you will see that I have the role storage blob data contributor. And if I delete this one, then all those SAS tokens that were signed by this user from the Entra ID, they will be no longer valid and they cannot do any operations anymore. When it comes to SAS tokens, there are a couple of best practices and pitfalls that I would like to bring your attention to. I cannot really emphasize this more or underline it. Always create short-lived tokens with expiry date. Even if it is necessary to add filter or IP addresses, do so. And always use the least permissions that are required for that specific operation that needs to be done. I highly recommend to always use user delegation SAS. If not possible, use access policies to generate SAS tokens. And when both of those options are not really possible, use the storage account keys to sign your SAS tokens. Treat SAS tokens as confidential entities. Store them in Azure Key Vault if necessary. Do not expose them to the whole world. Just make sure that the right client or right person or right user has access to them. Design around the ability to revoke those SAS tokens. If you're using the storage account keys to sign them, you need to go and rotate those keys and generate new ones. If you're using the access policies, you need to go and delete the access policy if the SAS token is expired. And if you're using the user delegation SAS, then you need to remove the role assignment for that specific security principle. Last but not least, and maybe again, always set an expiry date as short as possible. And to tackle the issues with the time zones, create the tokens with the start time a little bit in the past. So when the client is trying to connect, there will be no time zone issues. At the end, these are the three features that I really think are overlooked, because over the years, I always see people that are forgetting about lifecycle management and they are storing everything, for example, in the hot tier, even though they're not going to access them anymore. They don't need the blobs anymore there. Or they don't know about the data redundancy and replication strategy. They face an outage and their system is not fault tolerant against those outages, while it is highly important for them to always, for example, being available. And when it comes to SAS tokens or shared access signature tokens, it is more secure than using the storage account keys to connect to the storage account services, because you have more granular control over what the client can do and cannot do. And also you have the ability to revoke them whenever necessary, more easier than regenerating the access keys. There are certain scenarios that also the SAS URLs would be way helpful. For example, you don't want your backend API to be just a proxy to upload a file, because you could send the file to your backend API and then backend API uploads it to the storage account, right? But you could also generate an upload link and give it to the client, and the client directly uploads that to the Blob account. And that's where the SAS tokens, for example, could be very, very, very beneficial by just providing the certain operations and also within a certain amount of time, so the client do not have full access to the storage account. Furthermore, in such scenarios, you don't need to be worried about how you could scale out or scale up your backend service, because the client is directly connecting to the storage account and can upload the files there or download the files or from that storage. If you also are interested to know how to programmatically generate the SAS tokens, I've written a blog post covering all the concepts that we have talked in here. And for the SAS token parts, we are covering that in the blog posts from the coding perspective and not from the Azure portal. Thanks for staying with me. What do you think about these features? Add your comments in the comments section below. And دمتون گرم.